So, hello everyone. Actually, I can't see. Is there a way to see? Oh, 6 participants. Is that our whole group?
Hold on a second. I'm making you co-host so that you can share your screen if you wish.
Sure. For now, I'm not gonna do that. I'll do that in a moment. I will be talking about Uniswap today. Maybe really basic stuff. And maybe we'll have some time to move on to other things like balancer and maybe curve. But I'll kick off with Uniswap. So I'm not sure like how much you know, and therefore I'll just go from the ground up. So Uniswap is a decentralized exchange. It's on chain. And basically they have removed the order book completely from it. So the way it works, so you basically you can exchange any ERC20 token into any other ERC20 token. Uh, Ethereum, for example, Ether is a protocol level currency that is used to meter the transactions, and so it's not an ERC20. So what you do is but you can still use that, because what you do is that you can wrap it. Maybe you've seen the WETH currency, and WETH is precisely a wrapped ether, so it's one-to-one. And so what you do if you want to trade Ethereum is that you wrap Ethereum into WETH, and then you're able to trade that. And so that way you're able to trade Ethereum versus any other ERC20 and any other ERC20 versus ERC20. But for that to happen, you actually need to have a liquidity in the pool. So the pool is this construct. So in Uniswap, it is basically it literally sits in a smart contract that has half of the monetary value in one token and half the monetary value in another token. So what sets the exchange rate though is the initial quantity of the ERC20 tokens that you supply. So if you denote as the first token X1 and the second token is X2, then if initially when you supply those two into the pool, you will create the pool with the exchange rate of X2 divided by X1 units per X1 unit, right? So if you, for example, supply 100 of asset 1, and 100 is our X1, and 200 of our X2, which is our asset 2, then you're obviously getting 2 of asset 2 for each unit of asset 1, and that sets the exchange rate. But keep in mind that the monetary value of those two must be equal, 50% in that and 50% in that. So asset 100 is in fact the same monetary value as 200 of X2. I'll have a spreadsheet here, so I'll show all of that just to make it clear. And so that's your liquidity pool, and that sets your initial exchange rate. Price can obviously vary during the lifetime of both of those assets. And for that, you have arbitrageurs that go in and arbitrage away any price discrepancies. And so, for example, if your asset 1 goes up in price, then you obviously need less of it in the pool given the same price of asset 2, because the monetary value of asset 1 half is now actually more than it was, so you can trade away the slack, and that's how you arbitrage in those pools. if, for example, that's, by the way, that's the only way that you can move the price is by swapping any one of the assets in the pool. You can either swap one for two or swap two for one, and only that thing actually moves the price. If you add liquidity, then that just moves the curve, the constant product curve. I'll explain that in a moment. Um, so that's that. Okay, let me maybe now share my screen. Desktop. Wait a sec. Yeah, this one. Okay, should be able to see my screen. Yeah. Uh, I think so, right? Do you see it? Yeah. Okay. Yeah. Cool. So I just like played around over here. It's not very important. So this is how it goes. I guess another thing that I haven't just mentioned yet, and just super important, is the like how did Uniswap manage to actually achieve this? How did they remove the order book, and how does this all work? The reason that this works is that they have they keep constant their invariant of one token multiplied by another token quantity, and that will equal k, and so that they keep that invariant, and they determine the price through the use of that invariant. So what do I mean by that is if you denote I'm gonna just zoom in so you can see this better. So if you, maybe this is too much, if you denote as x1 the quantity of your asset one that you initially deposit, and x2 as the quantity of your second asset that you deposit into the pool, then what Uniswap does is that they multiply those two numbers to get back k, not kurtosis, just k. Just a sec. All right. And so whenever you have trades occurring, then they keep this constant. So let's have an example. Assume that you have added. You're the first liquidity creator in the pool, and you've added. Let's assume that our x1 is Ethereum, and our x2 is DAI, for example. So Ethereum, everyone knows what Ethereum is. DAI is a stable coin, which means it's a decentralized stable coin, which, and they try to back to $1. So DAI is supposed to be $1 at all times. And so we are the first pool creator, and we add 100 Ethereums, Ethers, and we add, well, WATs, as I said, you can't have Ether, and then 10,000 of DAI. So like, what is the exchange rate right now? The exchange rate is RX2 divided by X1, which is that divided by this. And so one ETH costs this much. And our constant product right now is X1 multiplied by X2, and it's this. And so this is exactly what Uniswap keeps constant during the trades. You obviously can have people jumping in and out in terms of the liquidity. Like you can have people add liquidity in between the trades and remove liquidity, but that does not affect the exchange rate. And so now imagine that someone comes in and they want to trade, they want to swap their DAI for ETH. and so they bring in 100 DAI, and they want to get out ETH. So what happens now is that our X2 will go up by 100. That's just given. That's what that is what will happen. So this is what we will have. Now the question is, what will be our X1 in this case? And remember this this K over here. Well, it has to be constant, and so we find our X1 by doing this. So we divide the we divide our constant by that, and so we can determine how much ETH that person bought. And so they haven't bought 1 Ethereum, but they have in fact bought this much, right? And so they haven't bought 1 Ethereum precisely because of this invariant that we keep in place. And so if there was no such thing, if there was just like a plain inventory of X1 and X2, then obviously we could run out of one or the other. And that would just be called constant sum, right? Because we would just have quantity of this plus that, and that wouldn't be constant product. The reason I'm saying it would be constant sum because Curve found a clever way to improve on the Uniswap slippage by finding their own invariant, which incorporates both the constant sum and constant product. So they have constant sum when it is close to the initial exchange rate, so that you don't have as much slippage. But when you are running out of your inventory, then it starts kind of hitting you, and you get the slippage. So this would be like an equivalent of having a Uniswap on leverage. So this is what constant product means. And if you want to have a look at what that looks like, it's just basically x times y equals k for so this is this is the curves. It's probably hard to see. So this is it, right? So you have quantity of x over here, and you have quantity of y over here, and your price is the slope at the point. So initially, when you supply the liquidity, you're starting here, and then as you buy one or the other, you're moving around this curve. And so if you look at Curve, for example, right? What I was just saying now. So this is the this Uniswap, and Curve will have a little bit better price for you over here. This is the Curve is the blue line, and then constant price is just as I said, the sum of it's like perfect, but I mean you can run out of inventory. So that's that. And then like what is the point of you adding any liquidity into the pool in Uniswap? Well, for one, you would be getting trade fees. So each trade, so in this hypothetical example, you just get back the difference. But in fact, you would get a little bit less since you also have 0.3% or 30 basis points fee. So so that's multiplied by that. So you would actually pay this much for executing the trade to the liquidity providers pools, right? So you would get back this much, and this would go into the pool, and that is how the pools are actually making money, if they do make money. So if the pair is quite popular in terms of trading, then obviously you'll get a lot of those trading fees, provided the size is also reasonable. And so that's the incentive for you as a liquidity provider, and to be providing anything to those pools. But then due to the construction of this invariant, there are some risks in here as well, and those risks are associated with the this thing called impermanent loss. But recently people have started calling it divergence loss, because the name impermanent loss suggests that you can revert that loss, which is true, but generally, the price does not stay at the same place, does not return to the same place as you have provided liquidity, and so people are moving away from that terminology into the and they call it divergence loss. So what is this divergence loss? This divergence loss defines what you're losing out if you were to simply hold the supplied liquidity in your portfolio. So to demonstrate this, I have constructed this example over here, but it will be here at the top. But it will be better if I just compute all of those things from scratch, so that it's clear. So let's do this. So we have this ETH and DAI over here. Let's remove this thing over here, and so our price right now. Let's assume. In fact, let's amend our example a little bit, and let's say that our x2 is also 100, and so this would be the case where 1 Ethereum equals 1 DAI, x2 divided by x1. That's our initial price, and let's have a column over here that defines the change in this, denotes the change in this price. So let's do change in the initial price. Let's just do the multiply this, okay. And so our price could go all the way to well, almost 0 or 0, which would be minus, let's say, well, let's give the lower bound of that. That would mean a decrease of 95%, and this would be 1 plus change in the price. So we just do that. This is the change from the original price, and then let's just move up in the blocks of 10%. That's it. And just extend this. Okay, so now what we need to figure out now is what is the, first of all, what is the new price? So our initial price was this, and we multiply that by our new price, and our price over here in R39 is always constant. It's the same. Here's the dollar sign here. That's the new exchange rate, right? So, for example, if the new price is 0.05, then that means that for every unit of x1, we now get only 0.05 units of x2. That means either that our x1 devalued, x2 increased in value, or a bit of both. Okay, so in order to measure our the value of our, so in order to measure the impermanent loss, so let's first define what the impermanent loss is. impermanent loss is how much you lose out if you stay in the liquidity pool versus holding. So holding is just holding your initial holding your liquidity provision. So in this case, we have provided 100 ETH and 100 DAI into the pool, and so we would just track how much both of those, the value of both of those, and the pool value is simply the pool value. And so you would do pool value divided by your hold, and you would have something like something less than 1 or 1, and so you would always have a loss. And that is due to the convexity of our invariant x times y equals k. So to measure this, we need to first decide on whether we want to track the value of the portfolio in x1 or x2, but really doesn't matter, because if you it doesn't matter because the loss that you'll make is the same, because half of your portfolio is in x1 and half is in x2, so it doesn't matter what you track. So if we do a value in pool value in x1, then our x1 obviously is just this is our constant, this is our new price, and so to determine how much x1 we have in the pool, we must use our constant over here, k. So k is x1 times x2, and we also have the new price, which is x2 divided by x1. So in order to get x1, you need to take the, just give me a sec, x1, x2, x2, x1. You need to multiply your k by the new price. And so this is basically x1 times x2 times x2 divided by x1. And so two x1s cancel out and you get x2. Okay, this is wrong. You need to divide. So square root of k divided by that. And so that should be right. x1 times x2 times x2 divided by x2. Yeah, that's right. So this would give you x1, but you also have x2 in your portfolio. And your x2 would be constant divided by your invariant, which is this, divided by what we have just computed over here. But this is x2, and you need to convert it into x1. But we have x1, so you need to divide by the new price. And that is your pool value in x1 with x1 and x2. And we just extend this all the way down. I need to fix those things. This is a bit convoluted. I'm pretty sure there's some things cancel out here, but so this is how my brain computed it this time. Let's just confirm that this is correct. So this is x1 times x2 divided by x2 divided by x1. So you would flip x1 x2 times, yeah, okay, this is correct. And so therefore this is correct. This would give you x2, and then you divide x2 by x1, yeah, okay, this should be correct. This is our pool value in x1, and then our hold value in x1 would be obviously x1 would stay constant since you're not in the pool, and so that would be just 100 all the time over here. But we also need to add how much X2 is worth in terms of X1 during all this during all these price changes. And so we have our price once again of X2 divided by X1. And so we have this 100 as well. That's X2. So that's what Q39. And that's X2. And so we need to divide, I think, right? X2, X1. Yeah, divide by this. Like that. And so we should have that the right column is always larger than the left. That's correct. And so our impermanent loss is then that divided by this, and then 1 minus that, and minus, so this is how much we lose out. And just extend this formula all the way down. So what we should see, if the calculation was correct, is that if we if our price doubles, i.e. goes over here, then the loss should be the same if it goes if it falls by a half. Because if it falls by half, then in order for it to go back to the price from which it fell, it must go up by 100%. So so somewhere in between those two numbers, we have something like -5 or 6. And then, yeah, it looks like our calculation is correct. In fact, there is an analytical form for this. You can find it in Uniswap Advanced Understanding Returns over here, and the formula is this: is 2 times square root of price ratio divided by 1 plus price ratio minus 1. That gives you impermanent loss straight away. And this is how that curve would look like. So they actually start at 100, which is, well, they just denote the original price at 100. So 200% means that the price went up by 100%. And so that would be the same as the price falling by a half. As you kind of draw the line, you'll see that that's like true. The loss that you make is the same. Maybe just also to note, this price ratio over here is actually your old exchange rate divided by is your new exchange rate divided by your old exchange rate. And if we sorry, where's my here? If we were to plot this, then we should get something similar. Let's just convert this into percentages. And then if we select this and insert chart, remove this blue line, then this is our impermanent loss, just like what we have here in Uniswap. And so that's the biggest issue with AMMs, is that it actually it may be this is my cat, sorry, I knew that would happen. Go away. What was I saying? Yeah, that's the biggest issue with AMMs is the impermanent loss. More often than not, you actually lose out on the price variability. And as you know, like all Ethereum is on a bull run, and altcoins are on a bull run, and everything goes up, and so that's a very real risk for you, especially if you have a sizable portfolio. then this is definitely something to consider. There are other AMMs such as Curve. Curve is an AMM for stable coins. You also have Bancor, and they have tried to battle this impermanent loss in their version 2 with their elastic supply token BNT. And the way that it works is that and in fact, you can even supply one-sided liquidity to Bancor, and they will supply the other half in BNT token. And from first sources, though, it is sometimes you're not able to supply that liquidity simply because there is like a quota on how much there is space in a particular pool. So for example, for the link token, you can have maybe 200, maybe 500 a day, and then it would just that you can add to one side of liquidity and then just go away very quickly. And so if you have a large portfolio, you would have to be doing that quite a lot. And obviously the gas fees are not cheap nowadays, and so this is a very real problem and needs a solution. So that's Bancor. They use their own token to incentivize people to add to the pools and to battle the impermanent loss. And so if also if you add the liquidity to Bancor and you want to be protected from the impermanent loss, then you have to hold each day you'll get 1% protection from the impermanent loss. And so if you want 100% protection from impermanent loss, then you need to hold your liquidity for 100 days in the pool, and that's a very long time. Balancer is the generalization of Uniswap. Balancer uses also constant product, but it's it is extended to n coins. You can have however many coins that you like, and they can in fact have different weights. These are the pools in Balancer. I'm going to comment on this as well because this is quite worth commenting on. So for as you can see, this pool has 4 assets. Zoom in. It has whatever DPI, I don't know what it is, WBTC, wrapped Bitcoin, compound USDC, and wrapped Ethereum, and each one is 25%. In this case, our invariant looks like, let me Google this, Balancer invariant. So yeah, this is a cool thing. So if you had 3 assets, X, Y, and Z, then this is how your oh, you know what? Then this is how your invariant looks like so X is the quantity and Y is the quantity that we have looked just now, right? And then just have an extra dimension, but it's not just 3 dimensions. You can have more. I happen to have a plot of such a thing. I've done this just recently. Let me just dig this out. It's in Balancer, I think. Is it in Playground? Yeah, it is in Playground. So AMMs. Oh, I'm already in here. Python Playground. There. That's our constant product surface in case of Balancer. And so, as you can see, this is the quantity of asset X. This is the quantity of asset Y, and then how much Z you need. As you can see, like we have this contrived example that I've made. Very few X's, very few Y's. And so, okay, so the K in this case is something like 1,000, because when X is 1 and when Y is 1, our Z is 1,000 over here, right? So obviously, if you have very little of X and Y, then you need to compensate that for, if your K is 1,000, as in this case, and you need to compensate with the quantity in Z. And so now, you have exchange rates of X in terms of Y, X in terms of Z, and it's much more interesting. And then you can have different weights as well. In this case, the weights are 33% each. That's why you have 1,000. If you had different weights, that would be different. And the equation looks like like this, like that. So you just multiply all the quantities together and you raise them to the power of their weight. And so this weight will stay constant at all times, same as V, unless people add or remove liquidity. And once again, if people add or remove liquidity, it doesn't affect the exchange rate. And so in this case, you have like 25%, 25, 0 to 5, 0 to 5. And I also said that this is worth commenting on. Because as we have seen from our Uniswap. Oh, my cat again. I'm sorry. You just have to bear with the cat. It just likes to stand on the table. And so from this example, right? We have those. Oh my God! He just explained. Right. So 98 and 2%. That's what I was talking about. This is our impermanent loss if our weights are 50 and 50 in both assets. But you can achieve different impermanent loss if you adjust those weights. And so what people do sometimes is that they put in 98% or 95% stable coin, and then the remaining 2 or whatever or 5 would be your volatile asset, and that way you are actually collecting the trading fees, and you're not as exposed to impermanent loss. And you would think that 98% versus 95% is not that much difference, but in fact it's a huge difference when you put those numbers in and you compute the impermanent loss. Right. Okay. So I think maybe it's worth also talking now a little bit about Curve. So Curve initial Curve's white paper was called Stable Swap. And so what this guy did, Michael Yegorov, is that he said, okay, Uniswap is not that great for similarly priced assets, and so what I should do is I should come up with a better algorithm than Uniswap for similarly priced assets, so he did that by finding a different invariant to Uniswap, which combines a constant sum as well as constant product invariance. So here he shows what the constant sum invariant is, and this is the constant product. He also quotes Balancer, which is generalized Uniswap. Uniswap would be, the weights would be half and half, and that's it. And you just have 2 coins in there. And that same graphic that I've showed you before, this blue line is Curve, and this dashed purple is Uniswap. And so obviously you get a better price for exchange rates that are close to the initial exchange rate. And of course, if you're doing this for stable coins, then most of the time you should be on this line if you have sufficient liquidity in the pool. And so you would save like this much, the difference between the two lines, if you were to swap one stable coin for another stable coin. And so where is this? Just some definitions. So this is the equation that he came up with. And so the sum of so xi is the quantity of coins, is the quantity of coin I. And so if you sum up all of these coins, then you'll get d like this. And so when you do that, you'll have I'm not sure if I'm pronouncing this correctly, chi, and then times d to the power of n. And the same is the case here on the right hand side. And so those two would cancel out, and you would have just the constant product. And so now if your chi, for example, is 0, then these two cancel out and you just have a constant product. But if your chi grows, then this is like Uniswap on leverage, because this term and this term, they suddenly have more weight than this one. And so if chi goes to infinity, then you are left with constant sum invariant, because your chi's cancel out and you just have your constant sum. And this would only work if stable coins were always similarly priced, but stable coins do jump around from time to time, and you need to make your leverage dynamic. And this is the value that you should use to make that happen, so that leverage adjusts if the prices do happen to jump around. And this equation, it does not have. So if you want to find out how many coins of xi you need to give the person for their xj's, or vice versa, then this doesn't have a closed form solution, and you'll need to iteratively find it. And amazingly, they have implemented this. And the reason I'm saying amazingly is because having loops on Ethereum is incredibly expensive. But they have implemented this, and also interestingly, they use Viper to do that instead of Solidity. So Solidity, most of the developers in blockchain, they use Solidity to code up the smart contracts, and you can do assembly level, very low level optimizations there with Solidity. But it's very it's not as easy to write in as is Viper. So for example, Yearn is also written in Viper, and it's basically, if you want to do any maths on blockchain, then you're better off going with Viper. And that is exactly what they did. They implemented this in Viper. And cool thing is, during his simulations, they have gotten 312% APR by letting people trade in those pools. It's like the efficiencies that he got from constructing different invariants in Uniswap for stablecoins, and that is why Curve is so popular, because they have just a different invariant for stablecoins, which is better. Well, that's that. I guess I'm open for questions because we have still 13 minutes. if you have any questions. I don't think I can see. Don't think I can see the chat. So if you just wanna jump in and voice the questions. Oh, I can see chat. Okay, I just see. Yeah, no questions. If no questions, then I guess we could finish off earlier.
Highness, if you allow, I would like to ask a question. Thank you for your presentation. I'm wondering, because as far as I understand it, the impermanent loss is defined as the comparison of two alternatives, right? Holding one portfolio on the market and holding one portfolio on the pool as a liquidity provider, right? So the impermanent loss then is the difference between what happens if I put my money into a pool compared to what happens if I hold the same assets in my own portfolio. So then the question becomes, how is it even feasible to compare the definition of impermanent loss between different protocols, since you will not end up holding the same portfolio, right? So in the case of, in a situation where you say that you are going for a curve-like invariant where you hold only stable coins, then the impermanent loss that you experience is not comparable to an impermanent loss that you would experience in Uniswap or in a balancer-like environment, except if you hold the same assets, right? So only if you hold the same assets, you can compare impermanent loss over different protocols. How do you account for that?
Well, I mean, that's a valid question, and you've answered the question, right? You said that you need to hold the similar assets to account for that. So I mean, I agree. If it's I mean, it doesn't make any sense to compare curves invariant for stablecoins and Uniswap's invariant for non-stable coins. It's just obviously it's apples and pears. But even if you use Uniswap and you have and you compare stable coins on Uniswap with stable coins on Curve, then the answer is clear which one is the winner. But then even then, maybe it doesn't make sense to compare those, because that's the whole purpose of Curve. It was to construct such an invariant so that it's better for stable coins. So maybe it's actually even something for Uniswap governance to determine if they would like to have different invariants for different coins. Have the curve-like invariant for stable coins, and then have their own invariant, or maybe something more optimized for other coins. Another thing is obviously also the capital efficiency. Is that you may have numerous pools in Uniswap that share the same. You can have one base in pool 1, and that base is the quote in pool 2, etc. And so, like, you could actually utilize the shared capital efficiency throughout all of the pools to have better slippage. Now, this is not answering your question about impermanent loss. I just a bit went off tangent, but that is in fact also what Balancer released, announced a couple of days ago, that they will actually do that for better capital. Anyhow, to return back to your point, I completely agree with you. It just doesn't make sense to compare some with the others.
Yeah, I agree. I mean, there are two ways to approach this topic. So one idea is, as you say, to use different invariant functions for different AMMs or for different applications to serve different purposes, right? To agree that if you want to swap stable coins, for example, then you should take this invariant because it has nicer properties or it has better, performance over a specific metric. This would be one way to deal with it. And the other way how I think we could deal with it as well is to introduce generalized metrics. So to think of something as a generalized impermanent loss, or to think of something as a generalized slippage, or a generalized capital efficiency that would allow you then to perform comparisons between different protocols, right? So, so these kind of new metrics would then account for the fact that these protocols have differences and try to introduce a level of abstraction that would lead to feasible comparisons.
That sounds interesting. Have you done some research in that topic?
This is actually one of my current research topics. Yeah, so I'm working on these kind of generalized metrics to see which performance of different AMMs so we can measure. Yeah.
Oh, that's very interesting. I'd like to have a look when you're ready to share.
Yeah, whatever. So like we're working on these kind of topics on a daily basis, and I mean, what I can tell you is we treat all AMMs as the same thing. So like from a mechanical perspective, they are the same things, right? So you have pools, and given these pools, you have three or three different mechanisms that you define, which is add, liquidity, and swap. And then the only thing that these AMMs differ in is the invariance, the definition of the invariance function, and the pool structure. So how you account for different weights and number of assets in the pool. So if you now step back one step, right, and say, let's loosen these assumptions and say we talk about a pool that has n assets and omega weights, and has a generalized invariant G. Now let's talk about what does this mean for metrics, for mechanisms, and for asset prices. So leveraging this onto this level allows us now to compare things on the same level, and also from this derive properties of the AMMs that we would wish to have, such that these metrics are optimized. So this is the purpose of my research.
This is very cool. This is very interesting. I'd love to have a look.
Yeah, sure. I mean, as soon as it's written up, you can have. Yeah.
Awesome. Thank you.
But yeah. All in all, thank you for the presentation. It was very cool to follow this step-by-step introduction to the topic, and having these comparisons between the different protocols. So this was very nice.
Oh, thank you very much. I'm sure that you haven't learned as much from this.
It was very interesting. I mean, definitely you can see it's always something new to hear. Like every time you listen to such a presentation, you always have new information and new perspectives. So I did learn my fair share through this presentation. Thank you.
I'm very happy about that. Thank you very much. I guess if there are no more comments or questions, we could probably wrap it up.
Great. If there are no more questions, I'm going to close the session. Thank you very much, Nas.
Thank you.
And thanks, Chris.
Thank you, everyone.
For question.
Bye.
Thanks.
Thank you. Bye-bye.
Yeah, bye.
Bye.